Hello everyone, welcome to my presentation. Today I'm going to be discussing inertial measurement units and whether they're an effective way of assessing gait in a Parkinson's disease population. So first of all, what is an IMU? IMUs are just wearable devices that contain sensors. IMUs can be used in several different kinds of environments, but as biomechanists we use them to assess uh, variables in gait or sprint performance such as stride length and stride frequency. This is an example of an IMU used at Cardiff Met. It's called a Blue Trident IMU. Blue Trident IMUs use triaxial accelerometers, angular gyroscopes, and magnetometers all in one. Accelerometers are used to measure acceleration, gyroscopes are used to measure angular velocity, and magnetometers are used to measure position or direction. And when I talk about triaxial accelerometers, I'm just talking about three axes of movement, so medial lateral, anterior posterior, and vertical. Like I said, as this might be an IMU might be used by a coach to assess sprint performance by being able to measure variables such as stride length and stride frequency. And another reason a coach might use these IMUs over different kinds of IMUs are because of the high sampling rate. So a Blue Trident IMU can sample up to 1600 Hz. So compared to other IMUs, this is substantially greater. But IMUs are also being used to provide objective feedback, information on training intensity, and competition loads. There are more applications for these in different environments, but we'll get to this later on. So these are some of the advantages and disadvantages of IMUs. One advantage is the power consumption and how they're implemented in smart devices, but they also can be used as a cheap alternative to measuring gait compared to the gold standard, which is motion capture. However, it kind of depends on which IMU is being used, because a Blue Trident IMU is quite an expensive IMU, but you might only need one to calculate kinetic and kinematic parameters, whereas low-cost IMUs you might need multiple of in order to generate or get accurate results, accurate and precise results. So this kind of hinders the affordability aspect or advantage, because if you need multiple IMUs, then it might get kind of expensive, where a coach might not be able to afford this kind of device. One disadvantage of IMUs is they're all prone to drift. So even Blue Tridents, so high cost, low cost, Blue Tridents might be less affected by drift, but they are still affected by drift just because of the sensitivity around in the position. Um, Another disadvantage is they're susceptible to noise, which might affect accuracy and precision, and also the number there are low. If you use one single IMU, then there is a lower number of kinematic parameters, so data that can be generated from an IMU. There is another disadvantage of being kind of unique. Well, it's hard to interpret, so the complexity of being able to interpret data from an IMU. So can a regular coach do this with an athlete's data? So there will have to be someone to train whoever's using the IMU to be able to interpret data, otherwise it's not relevant. Okay, so first of all, I like to define what gait was. So gait is just the aspect of walking. It's a learned motor skill which aids locomotion. Parkinson's is a neurological condition that progressively gets worse over time. So is there a link there? There is. Gait disorders are really common or very much associated with people with Parkinson's disease. So we can see from this figure by Morris et al. And Farn that they're not problems, but these are things that or disorders that affect people with Parkinson's. So we got bradykinesia, which is refers to the slowness of movement. We got akinesia, which refers to starting or the ability to start or maintain the movement. And then we have freezing of gait, which, as we can see from the stat at the bottom, is very common amongst, well, 50 to 80% of people with Parkinson's experience this disorder. But freezing of gait is basically when someone might feel like they can't move and they're temporarily frozen. And these all seem a bit daunting, so it's quite an important thing to address. People with Parkinson's also exhibit like more variable gait patterns and higher left-right step asymmetry than people without Parkinson's, so there is an increased risk of falls in this population. Thor Patel explained that in this kind of disease, it is important to be able to monitor and track normal routine, like people's daily routines, and it is crucial in understanding like their state and if they're progressively getting worse. So this is where IMUs come in. Okay, so can IMUs be assessed to assess gait in a Parkinson's disease population? So from this, we can see IMUs do have the capability of capturing a wide range of spatio-temporal characteristics of gait. So these include, well, the variables affected in a Parkinson's disease population are variables such as reduction in stride length alongside lower walking speed. But it's also important to understand spatial-temporal parameters as they serve as an important component of monitoring gait impairments. But when we refer to spatio-temporal, we're just referring to different points of time and space during one's gait cycle. Gait can, let me this graph up. We can see from this graph or figure, sorry, that by Brognara et al., who conducted a systematic review of where IMUs are typically placed during studies or to assess someone with Parkinson's or their gait. So we can see the highest one was from their lower back, and gait can be collected from the single use of an IMU. So this is predominantly placed on their lower back. IMUs are cheaper than gait systems. They kind of overcome the limitation of being laboratory based. We'll get further into that when we talk about the validity, but they're also now being implemented into people's homes and populations of patients. So people with Parkinson's, people with stroke, and this allows for the real-time, reliable, continuous monitoring of their disease, so of Parkinson's. Okay, so this is about the validity and reliability of IMUs. So Zago et al. 2018 determined that IMUs were reliable in assessing most spatiotemporal gait parameters with people with Parkinson's disease. There's another study conducted here by Felius et al. That discusses stroke or talks about IMUs in the population of strokes. Now I know this is a different population, but I thought it's kind of effective in showing that IMUs are reliable and effective in different kinds of populations, right? It's also important to mention that the validity of IMUs, Dargo et al. Showed that IMUs provide more ecological validity compared to the gold standard of gait, as they're not confined to laboratory settings and can be applied to real life environments. So this is very important in progress. Like, what do we do when we progress? So when we're outside the lab, how can we help people with Parkinson's? How they help them monitor and stuff like that. So to conclude, IMUs provide a more practical method of assessing gait compared to the gold standard. So the ecological validity again, being able to provide real-time monitoring. So when people are at home, being able to be reliable as well. But there are some things to consider with stuff like training. Can a patient assess their own IMU data? Can they do that themselves without having someone there? So training will be required. The reduced accuracy and precision, if like a single IMU is placed, the lower number of kinematic data that can be generated if there's just a single IMU being used, but also the noise, the susceptibility to noise. But overall, I would say that there is definitely a use for IMU to analyze gait in people with Parkinson's, as there are several advantages for this. But also, it's been validated, it's reliable, and it's a reliable measure of detecting gait abnormalities in this specific population. Here are my references. Thank you for listening.